All right, so just like it says up here on the board, trig for physics. All of you have been through geometry, so you've all at least been exposed to SOHCAHTOA. We are going to talk about that today, but we are not going to go into a full-blown explanation and derivation of all the different trig stuff that you guys will learn or maybe have learned in actual trigonometry here at the high school. We're just going to talk about how you need to know and understand trig for the purposes of what we're going to do here in the physics class this year. This will become one of those things kind of like sig figs or scientific notation where I'm just going to expect that you know how to solve these problems and you know how you have enough of a fundamental understanding of the trig that we're going to do in here that you just know how to do it and how to manipulate those different things. Okay? So first we're going to go into some definitions. The first thing we want to talk about is we're going to always be describing some angle on a triangle. And we're always going to be using right triangles. It's not drawn on here. I guess I can draw it on here. But everything we do is going to be based on right triangles. That's how, in this case, the trigonometry that we're going to use works. Again, there's other trig that can do a bunch of other fancy stuff with different kinds of triangles. But for us, we're going to stick to right triangles. Okay? We're always going to relate to one or another of the angles on the triangle that is not the right angle. Right? So you have theta here listed. You also have another angle here. But generally, we're just going to talk about one of the angles on a triangle. And I'm going to call that angle theta if I don't know what it is or if I'm just trying to describe it or whatever. And then the other part of SOHCAHTOA is describing the other sides of the triangle. So in this case, I'm just going to write x, y, and z to denote the sides of the triangle. And then for the purpose of SOHCAHTOA, we describe these as the opposite, the adjacent, and the hypotenuse. Hypotenuse, N-U-S-E, N-U-C-E. That looks really wrong, but I'm going to let it roll. These signs, not math. How do I know how to spell hypotenuse, right? Can't be an S. That looks even worse. How does that look worse? How do you spell hypotenuse? Hey Siri, how do you spell hypotenuse?
No one was
H-Y-P-E-T-E-N-U-S-E. It is S-E. I was right. Looks awful though, doesn't it? Anyway, given our letters on this diagram, and we're talking about our angle theta, what is the opposite side from angle theta? What do I have that listed as? Opposite is y. Good. Which one is adjacent to the angle theta? Now this is the harder one. Is it x or is it z? Why is it x? Z is the hypotenuse. The hypotenuse is the one that is opposite the 90-degree angle. The hypotenuse is also the longest leg of a triangle in a right triangle. That's going to come in handy when we get to solving some of these problems. If you're solving for z and x is 10, right, and you get an answer for z that is 8, that can't possibly be the right answer. Right? The hypotenuse is always going to be the longest of any of those three legs of a triangle. So let's keep going. Let's not do it this way. Let's do it this way. So this should be familiar to all of you. SOHCAHTOA. You guys have seen this in geometry. I don't know how much you actually did with it or how long ago geometry was for all of you, but you can at least remember the moniker SOHCAHTOA. Now what this translates into is the sine of theta equals the opposite over the hypotenuse. Cosine theta equals the adjacent over the hypotenuse. And tangent of theta equals opposite over hypotenuse. So this is how we start getting into the actual equation side of this and how we can actually use this to solve some kind of problem. SOHCAHTOA is just the easy way to remember this, but ultimately understanding that O is opposite, H is hypotenuse, A is adjacent, and how those things are defined in the triangle that we are talking about.
How are tan and sin the same thing?
There shouldn't be, you're right.
That's what I was going to say.
SOHCAHTOA. Sorry, erase that. SOHCAHTOA. Tan is opposite over adjacent. Yes, they should not be the same. So let's practice. Let's actually do a problem with this. Here we have a triangle. And we have an angle listed here. And we have the length of one of the legs listed. And this is the beauty of trigonometry. Using those identities, the sine, cosine, and tangent, we can solve for the rest of the legs of this triangle. That's where this is going to become important and useful to us in physics. Because we're going to be given maybe an angle, maybe we're given legs, maybe we're given whatever, but we're going to be able to solve for the rest of this. So if I am trying to solve for this leg of the triangle, for whatever reason, it doesn't really matter. We're trying to find the length of something, the height of something, the whatever. X is what we're solving for. So we need to figure out what part of SOHCAHTOA is going to be handy here. S. So if I'm looking for X, what is X? Adjacent, opposite, or hypotenuse?
Adjacent.
Adjacent. What is 8? Opposite or hypotenuse? 8 is opposite. So if we've got O and A, we can use, in this case, tangent. Tangent theta equals O over A. Now we fill in the blanks. Tangent of 30 equals O, which is 8. A, which is X. And now this simply becomes an algebra problem that we can figure out. In your calculator, tangent 30 is going to be some number. 0.577 or something. And we're going to go through calculators right now. So when you hit tangent 30 on your calculator, what does it say? If it does not say 0.5773, your calculator is probably in radian mode, and you need to switch it. Hit the mode button at the top of your calculator. Go down to where it's radian or degree, and switch it to degree. Yep, and then just go back, just go out of mode. Yep. So hit mode. Good. And now tangent 30.
So we should put tan 30 in?
Yeah.
0.577. Make sure your calculator is showing 0.577 for tangent of 30. Good. You're good. Most of these should already be set, but if you've got a Texas Instrument calculator, you've got to set it to degrees. You got it? You're just good. All right, so next, what is under the hood of this is just a number. This is that 0.577 or whatever you've got in your calculator. So as such, we're going to solve this as a cross multiply and divide. So how do we solve this? Cross multiply and divide. 8 times 1 is 8. Tan 30 times x. Again, remember, this whole thing here represents a number, so let's just get rid of it. 30 x equals, somebody do the math here, 8 divided by tan 30, 13 point, call it 9. So x, 13.9, whatever the units are. Everybody got this? Written down? So now let's figure out the hypotenuse. I'm going to just erase this, start over. So now let's pretend we didn't have this that we already solved for. So now how do we solve for y? Y represents what? The hypotenuse. And 8 represents still the opposite. So which identity do we need here? Sine of theta over h. Sine of 30 equals 8 over y. I'm going to do the same kind of stuff here. Again, this is nothing magical. This is just algebra once you apply whatever trig function you need. The rest of it is just solving it with algebra. Make sure you're figuring this out on how to do this in your calculator. There is a worksheet I want to hand out that has a bunch of these to practice. There is one other way to manipulate this, and again, this is going to need your calculator. Let's say we have our triangle here with side length of, I don't know, 12 and 17. And now we don't know what angle theta is. If we have two sides of a right triangle, we can solve for any of the angles. So, given our angle is theta here, which identity do we need from SOHCAHTOA? Which identity is going to be helpful here? Cosine, right? If we have theta, we have the hypotenuse, that's the long one, opposite the right angle, and we have the adjacent segment to the angle. So we're going to need cosine here. Cosine of theta equals adjacent, which is 12, over our hypotenuse, which is 17. Now is when you're going to have to use, typically it's the second button or it's some kind of function button for your calculator. To solve this, you're going to do the thing that looks like this. And that is going to churn out our angle theta. Again, this is going to be somewhere on your calculator. It's probably just like second and the existing cosine button. So second cosine, 12 divided by 17 in paren. And you get 45. 45.1 degrees. And that's really it. So as it concerns triangles, however, the expectation is that you write and draw a triangle every time. Draw the triangle that's being described in the question, in the problem, whatever that is. Now your triangle does not have to be drawn to scale. Just draw some kind of right triangle. Make sure one of the angles is that right angle. And then label the rest A, B, C or X, Y, Z. Makes no real difference. Some of the people in earlier today were using O for opposite, putting that into your formula when you're trying to solve it. Just be careful using O, because that looks a lot like a 0. That's why I'm always using stuff like X, Y, Z, theta, A, B, C, whatever. I just would avoid using O for opposite in the actual formula when you go to start solving it, because it's going to look like a 0. It's going to confuse you at times. So this is Trig for physics.